Okay, so we're working a partial pressure question here. When you're doing these partial pressure questions and it says something about a sample of gas collected over water, you have to remember that some of that water has escaped into the sample as water vapor, and thus the water is contributing to the total pressure. So first step is to figure out, well, what is the pressure coming just from the sample of gas? And to do that, we know that the total atmospheric pressure is going to be equal to the sum of the pressure from the water and the pressure from the sample of gas. So you can just simply rearrange this and you end up with the pressure of the gas is going to be equal to the total pressure minus the pressure of the water. Plug your little numbers in. 756 minus, 17.54 tells us that the pressure coming just from the sample of gas is 738.46 torr. All right, now let's see if we can just kind of organize our data a bit. We have the, and I'm going to call the sample collected over water sample, and then we'll use dry for the dry gas. Let's see what we got. Our question tells us that the pressure of the sample, which we actually just figured out up here, is 738.46 torr. The volume was 326 milliliters. And label. And the temperature was 23 degrees Celsius. Of course, we'll convert that to Kelvin, which gives us 296 Kelvin. 296 Kelvin. Okay, and so now we need to kind of label what we have, what we know about our dry sample. Well, we know a lot about our dry sample because it tells us it's at STP. So we know pressure of STP is 760 torr, and we're looking for volume, that's our question, our X, and standard temperature is 273 Kelvin. So now at this point you can use the combined gas law, P1V1 over T1 equals P2V2 over T2, plug everything in, kind of write it out here. T1 equals P2V2 over T2. Let's plug it all in. So my P1, and we can just make that either side, so I'll just use my sample. P1 is 738.46 times V1, which is 326, divided by 296. Oops, sorry guys. Let me see if I can move this. Uh-oh. One more try. There we go. And we'll set that equal to my P2, which is standard pressure, so that's 760, times my V2, which that is what I do not know. I'm going to be looking for that, over T2, which is 273. Do a little bit of algebra, rearrange, and you should come up with V2 equals, with lots of decimals, because UT Quest doesn't follow sig figs, 0.292147 liters. And remember that our original value was in milliliters, so you just have to make that change to your decimal, move your decimal a few places. So if we kind of scroll back up to the question, looks like option 5.